My name is Liszka. I'm a program manager at Bitnami right now. And Wojciech Kocjan is an architect, and we will talk about Stacksmith. So the agenda is pretty simple. First, I will just give you an overview of Bitnami, because Bitnami is mostly about packaging and migrating and optimizing applications. Then I will quickly talk about Stacksmith. Then we have demo and questions. Actually, questions is the most interesting part for me. Please interrupt me anytime if you have any questions. If we will need more time to answer them, we will just put them on the parking lot, or we'll just get it back to it later. So I really like this quote, because it's exactly the vision of Bitnami. Like, make the applications deployment and applications packaging that simple. And it's what we actually do. From the very beginning, we were trying to make all different open source applications easy to deploy by anyone, not hackers, programmers. We're trying to bring it to everyone. And right now, you can actually download anything, installers or cloud images. Everything is for free. Everything is open source. So you can go to GitHub, get our Helm charts, get our containers, and we maintain it continuously. We keep it secure, and yeah, we make it awesome. So there are three main areas. One is application catalog. We have been working on this for the last 10 years. So we have more than 130 applications and different runtimes. And right now, more than around 50 Helm charts and more than 80 containers. And everything is kept up to date across different platforms. As I said, you have AMIs, you have Azure images, Google images, you have containers, you have Helm charts, you have installers and virtual machines, etc., etc. And we have a build system which automatically maintains everything. Then if you compare our build system to Borg, then Stacksmith is a Kubernetes, because we decided that we can't really scale. We don't want to onboard more open source applications to our catalog. But we said that we are going to let you guys and everyone just to do it on your own. That you will be able to package and maintain applications on your own. So it's about scaling, onboarding of applications. Also, there are some other use cases which are not really typical for Bitnami, but are really interesting to other users. And then the third area is about Kubernetes and open source projects. We work closely with Heptio guys, now acquired by VMware, with Days guys, acquired by Microsoft. We have very interesting open source projects like KubeApps for in-cluster catalog. We released recently like a layer on top of Kubernetes, Bitnami Kubernetes production runtime, BKPR. I think it was announced during KubeCon like a few weeks ago. And we have kubeless. That's actually a really good idea for a talk here. It's about serverless framework, sealed secrets, etc. So yeah, you can't really see that well, but I just wanted to let you know that the catalog is full of open source applications. So if you need WordPress, or if you need CMS, if you want TensorFlow and you want to get it running in 5 minutes, you just go to any cloud marketplace, or just go to GitHub and get Helm chart and install it on top of your Kubernetes cluster. So Bitnami toolchain, it's like the most important part of our system. We're working on that for several years. So what we do, we are tracking the upstream projects like PHP, zlib, Apache, web server, etc., etc. And we trigger builds for every new update, security update released in the upstream. And then we trigger those builds. So we build cloud images, we build installers, and we test them. And we test them in the native environment, and then we publish them.
When you say build, do you mean that like build like in Spinnaker when you have like a pipeline to build like I don't know like one of the artifacts like Docker image or AMI,
Yeah.
and then you can actually do that. It's just like entire pipeline when you.
Is it? That's entire pipeline. Yeah. So 1 second. Yeah. So we keep improving that, and we learned several lessons. And now, before we jump to Stacksmith, I wanted to share some lessons. The first one is automate everything. And just because Bitnami it's a project, but it's also a company, and we are a small company. And to be able to achieve what we do every day, we had to invest in automation. And here are some examples, because we also try to measure everything. So like 3 big security issues you have here. And the time we're able to rebuild and retest and republish everything across all different cloud platforms.
Question.
Yeah.
How do you track the CVEs and artifact versions and things like that? We have at Red Hat we have specific way actually to understand exactly what we ship where and what are the fixes and CVEs in there. And we build like entire platform for that so people can use, and I just wonder how do you do that?
I think we use Clear right now for CVEs tracking, but and we also have our CVEs tracking kind of service. But there is also one more idea, that one thing is to track CVEs. What's not easy, because even if you use open source CVEs tracking tools, you have to have an idea about white labeling, because there are plenty of CVEs that are not really patched. And let's say that you want to check, for instance, your container image, you can get 100 CVEs in that image, but actually you should not worry about that, right? So I think our main idea is just to follow update and just try to update as soon as possible whatever is available there. And this way we can actually avoid being so serious about tracking CVEs. But I can get back to you on how do we do it, because we have 3 different, I think, projects. Because there are some teams they use Anchor.io. There are some we have some kind of internal CV tracking system.
It's just not about tracking CVEs per se, but just knowing which versions are actually affected. And for example, from our perspective, when you think about RHEL, the flagship product that we have, anything that is built there, any package there is whatsoever, the version it is, any CVEs that is announced, like it's there, we immediately know which versions are affected, because we track everything from single code change to the release and to version, and then we collect everything in ratas. So you exactly know which fixes actually go to exactly which version. Yeah. And when the CVEs are announced, we exactly can let know customer that some of the operating systems or the containers that they are using are affected. So they should do something like that.
So the tool which should do it right now is Stacksmith, because we try to do it in Stacksmith. We do not have like the very specific tool that I can tell you that we use for Bitnami toolchain, but Stacksmith is about that, because you have CV tracking in Stacksmith, and you have like builds as well, and you can actually, it's about that you have to track and know exactly which deployment is affected by very specific CV and security issue. Wojciech, do you have anything to add?
No, but I think in our case it's slightly easier than in Red Hat's case, because we simply track the distributions that we build. So, for example, in Bitnami we build images for multiple clouds based on RHEL, CentOS, Ubuntu, and Debian. So we just track the four Linux distributions and the packages that they have. Well, there's also Oracle Linux, but I think that one is just So we do track it and we do detect when some package versions are affected. Our idea is slightly different. We wait until there is a fix for this at the upstream package repositories, and then we build it. So we track it by ways of I don't know, just tracking CVEs and then tracking if the versions we use are affected. Once we know that, then this is what we track in terms of how fast do we need to provide a fix. I think we actually track it from the moment that at least one upstream publishes a fix for it, because there is nothing we can do until at least one Linux distribution vendor provides a fix for it, and then we just track every single vendor whether they have shipped the fix. And because this is rebuilding the images, we don't have to go in and patch it. We just provide a newer version of the image with the idea that the users will either launch a patched version of the image, or they will somehow be responsible for patching it on their own, and we do work with the cloud vendors to notify the users. But the general idea is that we build a newer version of the image, deploy an updated version, and this is where we think this should be going in the long term. So as soon as we can track this detected from the upstream packages by Linux distributions, it's relatively easier for us.
The question: how customers know that there are things that they should update? How they know? Do you notify them somehow?
We cannot do this directly, but we work with the cloud vendors. So for example, the cloud vendors like Amazon, Google, Azure, Oracle, and any other cloud vendors, they track. If you choose an image from a marketplace, it's somewhere in the databases or any other storage systems that you've used a specific version of a specific application. So once we notify AWS, these are the images, these are the exact identifiers in the systems that were affected, they could then on their side fetch the exact list of users that were affected based on this data and just let all of them know.
So it's up to Amazon, for example, to do that.
Yes, but the cloud vendors are really interested in doing this because this makes them perceived as more responsible in terms of their users. So you're actually being asked to provide us detailed explanations on how to patch or work around any of the security issues as possible. So in some cases, there is a flag you can set in the image by not updating the system. We also try to provide it for yourself.
What about Amazon in Linux? Amazon could do that by themselves. Actually, Amazon Linux is just a mix of Fedora and RHEL.
Yeah, there's.
So they can do it by themselves, just to publish the Amazon Linux instead.
I mean, it depends what kind of.
You're asking whether they could just take the Linux distribution and publish all of the applications that we provide?
No. I mean they can actually, because at the end of the day, companies like Amazon actually are here to actually earn some money. So if they actually maintain their own stuff without actually paying you guys, I'm not sure what is the business model here, but.
Yeah, well, we have usually commercial relationships with cloud vendors.
Okay.
That's why, I mean, we have to have a way to pay everyone who builds it, assuming that everything what we actually build is for free, right, and open source. That's why, the answer to the question is there are just commercial relationships between us because we provide them with the catalog, and we provide the best quality possible. Does it answer your questions? And then at the end, documentation is also always rebuilt, and we try to have this rule in mind that every time you reply a question, just try to first create a documentation and then reply with the documentation. So it means that we track the number of answers with documentation link, and we try to make the number like close to 100%, right? Okay, so as I said, if our Bitnami build system is kind of Borg, then Stacksmith is Kubernetes. So at some point we said, okay, we don't want to keep adding more applications, or let's try to make it available to everyone, and let's scale it, and let's let people to do it on their own. So Stacksmith will just allow you to define your code, your configuration scripts. You are able to define your cloud native template. For instance, in case of AWS, it can be CloudFormation template. And that's an input. And based on that, we are able to generate images, containers, and deployment templates for different clouds. Here is an example of AWS or for Kubernetes. In this case, you will have a container plus Helm charts. And then you have this feedback loop as well, because we keep tracking. We keep track of CVEs and updates, so we will notify you when the updated image is available. And there are like 4 use cases. The first one is about security. Like, does everyone know what immutable means? Because that's kind of important here. Immutable, it means kind of static. Like, we try to foster new way of maintaining and deploying applications around CI/CD. Immutable, it means that you build your image once, and then if you have a new version of application or if you have anything updated, you build an image again, and then you just need to change, you need to spin up the new virtual machine or new container and substitute this version. Immutable, it means that there is no more SSH to the server. No manual changes on the fly. It's just not possible. And it's so much easier to keep track of what's actually running and where. It's so much easier to avoid mistakes, and it's so much easier to force and enforce some best practices. So the first one is about security. The second one is about migrations. So like, we may help you to migrate things, but also if you already migrated something, we may help you to refactor it a little bit or replatform, like so you can use cloud native services. The next one is more about making sure that every team follow the same policies, about best practices. And the last one is about service catalogs and like a kind of internal marketplaces. And Wojciech is going to talk more about that. So the next part I wanted to mention here, like immutability is not that easy. But if you take a look at this as an immutability ladder, we allow you to jump on different levels. So some people will just want to maintain their golden image, just to make sure that, I don't know, they have Red Hat and they want to have a very specific configuration for some services, Linux, etc. And they just want to make sure that it's always kept up to date. Maybe Red Hat is not the best example. Sorry? CoreOS, for instance. Then the next one is about if you want to have like very specific services configured in a very specific way. The third one, let's say that you have Java developers or .NET Core developers, and you want to make sure that everyone follow the same kind of configuration. And the last one is full immutability. So Stacksmith allows you to generate images, but also full templates, like optimized one. We try to allow like 2 different groups of people, developers and DevOps, to work like their own way. So in Stacksmith, there is no lock-in. There is no like only one way of doing things. You can integrate with any tools you want. There are no hookups to Stacksmith. You can actually generate things once and just forget about Stacksmith and use whatever you have, because the output is something what you can reuse. The output is cloud native template plus images, and everything is happening in your own account. So we don't try to do it in our own account. We just try to build it in your own AWS or Azure or other cloud vendors' accounts. Here's an example of Stacksmith integrating with different managed services like CloudWatch or RDS. And the summary, why would you choose this is continuous maintenance, generating templates and cloud images, and for me the most important, no locking. Okay, I hope it was not too long. Yeah.
Okay, so hi everyone, as Daniel mentioned, my name is Wojciech and I'm going to show you some bits of Stacksmith. There is one thing I think that Daniel didn't emphasize is Stacksmith is basically obviously designed as a commercial offering, but we follow the GitHub's approach that you can use, that we have free tier, which we're actually going to focus on. The free tier is meant in a similar way that GitHub works, that basically if you want to have a public project, like I think I'm in this one, Bitnami public. So like if you don't mind anyone seeing what you're basically working on, then this is available for free. If you want to have your own private, your company's projects that would be private so that only authorized users can use it, then obviously that is not free, but we've tried to follow the same model. And I basically, all or almost all of functionality of Stacksmith is available in the free tier. Obviously, I'm just going to use the AWS demo one just because it's set up. Obviously, I'm going to use the account that I have, which is not just a free one, but you can redo the whole thing on your own with the free tier account. There's one thing that happens when you onboard into Stacksmith, which is when you start using Stacksmith, which is you need to add your own credentials. I'm not going to go through this, but just to mention it, like, oh, sorry, a new project, like let's say Krakow meetup. Okay, and then it'll basically ask me to choose which cloud I want to use, and then I would have to follow the onboarding process, which is well documented, and it's basically, let me just show the next one, basically launching a CloudFormation template that we provide you with and just copying the output from it. And we take care of all of the onboarding. But I think I'll just use the account that I have because it takes a few minutes. So right now I'm using the Stacksmith UI, which is a good way of doing it. Stacksmith also has an API for all of the things I'm doing, also a CLI that you can use. So let's just try to package something. Let's say a Java app that will show up in service catalog. So, crap, to show up. Okay, that was too long. So here I basically define my application. The name and version is random. And again, all of this works the same with the free and paid accounts, so there is no difference here. My application just happens to be a Java application with a database. And I'm just going to choose to package for both because it's more fun this way. So then I'm just going to start the upload. So I already have my application built. This is just a WAR file that's going to get plugged into Stacksmith, to Tomcat, and Stacksmith is going to integrate it. We have multiple other solutions. I have some of my internal tests that I did that I'm just going to skip for now, but we have some built-in ones. It's possible to define other ones. We've tried to figure out what's a good way to define applications and customize applications that's going to be more or less consistent between containers and VMs, because obviously those are very different things, but there are some things that work similarly. So you can provide scripts. In this case, it's a build and boot script, because we know how to start Tomcat. In the case of custom applications that I'm going to mention in a while, this could be a build, boot, and run script. Build script does things at build time. Boot script just configures the application, and run script for for different types would be how to run it, because we may not know how to run your Golang application, and if you tell us, we will do it. So let me just, yes?
In terms of Tomcat, which version of Java would you use?
So this is actually using right now, this account only has, and this is how it's also configured in the free one. So by default, it only has CentOS. If you tell us which images to use, it's possible to use different ones, but we just use CentOS, and we just use the packages in CentOS 7. So this is just basically taking Tomcat from CentOS 7, because this way we could also, the internet thing is is wonderful.
My question was because with Java it's now tricky because our beloved Oracle actually changed the licensing with Java recently.
Yes.
So how do you handle actually licensing issues like that?
So by default we ship OpenJDK, which is what is shipped by CentOS 7. There's nothing preventing anyone from having the boot script replace it with Java CentOS 7 packages or RHEL 7 packages, because it's basically the same underlying libraries. But whoever does that has to have the license for it, and by default we just use OpenJDK, because when we were making those choices it was clear that we shouldn't be using anything other than OpenJDK for the same reasons. I think Java is a nice thing to show because there are many legacy applications. The problem with Java is exactly like you said, like there is no good way to run Java because some people may be running IBM Java, I suppose IBM Java still exists. There were other Java runtimes in the past. I don't know what's the state of them, but this could also be the case. So
this boot script is a shell script where you would like, if you have, there's just a shell script that if you want some packages or something like that, everything in your,
yes, so
your VM, you would do that there.
Yes, so we have the concept of stack template, which is some opinionated way of what we install, and because we chose Java, it's going to install Java from CentOS. It's going to set up Tomcat. It's going to do all of the associated things like set up a load balancer in front of it if you want to run multiple VMs. It's going to run RDS-based SQL database. So, and actually, This
image actually will use RDS, right?
Yeah, so we will build an image and a CloudFormation template, and obviously I didn't expect the internet to be so slow, so it's going to take a while. Yes, so I mean, what we'll do is I will finish defining it in a bit, and we'll just switch to a 1.8 ready build, because
it doesn't have to be a shell script.
It does have to be a shell script at this point. We're thinking what to do. One thing that I will mention, and I think this is relatively interesting to people that have different ways of working. We thought about 3 basic ways of integrating with it. One is if you have anything manually, like let's say I just have my WAR file and I just write a bunch of random shell scripts and I just test by uploading them, which is a fine way of doing it. It's not a convenient way, but it's fine. This is what you could do. The next step is, okay, I want to commit it somewhere, which I actually have committed somewhere. And then you can plug it there and it's just going to say master, but obviously this thing is preventing me from moving on. And then the third way is you will have a CI, which hopefully I will be able to demo. Anyway, there are 3 different ways. We're just going to go through with option number 2. I will try to do option number 3 later on if time permits.
How's that different between OpenShift's way of code to image?
Code to image is only for containers. Source to image is only for containers. We try to build a thin layer around containers and VMs that is generic enough that suits 90% of use cases. And then if you need to apply conditions like if container do this, if VM, I don't know, turn off or on huge pages, whatever else you need to do in a VM that you can't do in a container, you can still do it. But the idea is for 90% of the use cases, you can build relatively well cloud platform native images by just having the same layer of abstraction there. So, okay, it says finalizing.
You are just uploading the WAR file, whereas you could actually use the GitHub repo for that as well.
Which I will actually show in a bit. I will show how you can integrate it with Travis CI, which is also a free CI system. So I'm just going to, what I'm going to do.
I ask the question also because you can actually integrate also with Chef, Ansible, and whatever you want. Like there is no, like for now we started with shell scripts just because everyone knows shell scripts, and it's just like the plain way of defining things, Like before, just to give you an example of containers that we had with Nami.
I'll just break quickly. So I'm going to start build, and because I chose 2 platforms, it's actually going to kick off 2 builds. So with the same set of scripts, I'm going to build containers and VMs, and you can continue now.
I just wanted to explain why shell scripts. Before in containers in Bitnami, we had our own tooling to do some kind of magic to configure things, to install things on the fly. And developers in the open source community was complaining about that, just because it was, for some people, it was not clear and not easy to follow what exactly is going on inside. And right now we are rewriting most of it, and I think we did already, to shell scripts. Of course, we have some kind of shell scripts libraries to make some parts easy and drugs, but that's a big value for the community that they can actually go and find all these different scripts and they understand what exactly is going on. And then in the background, if you want to use Ansible or Dev or whatever, it's fine because you can actually execute from shell scripts.
Okay, so I have a build I did yesterday, foreseeing that it would take much longer than I thought. So this is actually a successful build. It's just for AWS, but we will show Kubernetes in a while anyway. So basically, it has the EMI, which is the image in Amazon. I have the CloudFormation template, and I have both the types of URLs. And I uploaded the same WAR file and used the same GitHub repository, which I will show in a while. I can basically just launch it from Stacksmith. It just points to Amazon's console that I hope will work faster than the upload. And it's just pointing me to the URL of my template, and I can just this template is basically built by Stacksmith, but you can generate it by Stacksmith. You can upload your own templates, or you can customize the one we have. We have documentation for this. This is just some set of opinionated features that we included by default, assuming that this is what 90% of the people wanting to run their Java applications will need. So I'm just going to say whatever else. I can change most of the settings, but I don't need to change most of them. I just need to type my database password just because there is no easy way to generate it. And I'm not going to choose the use me because it would be too easy. So right now I'm just applying some random settings that I memorized by heart. I just want to make it possible to connect via SSH and connect to the application. This is just a mask of what that should be used, which is passed later on. I disabled backups just so that launching is going to be faster. This is advanced settings, like if you want to run it inside a specific VPC, which is networking in Amazon, you can do it. If not, by default, just going to launch it. This is just standard launching in AWS. So there's nothing really Bitnami specific. I just wanted to kick it off because I'm quite sure it's going to take 5 to 10 minutes, which is a good excuse to mention what we're doing in the template, because it's just going to be launching and launching. So I'm just going to go back here. And we can just view the template in Designer. And you can see what we're basically doing there in a while, obviously. Okay, awesome. Now, if I just stop everything from showing up on my screen. Okay, here it is. So I don't think I'm going to go through all of it, but it seems okay. So, but I think some things are interesting. So we create a database, which is just an RDS, as I mentioned. So the idea is that you tell us what you want to run. If we know how to run it, we'll just generate something that's relatively easy to use. In this case, this is RDS for Amazon. For Azure, we use Azure Database for MySQL. All of the networking is also generated by us. This is generated conditionally. So if you give the existing VPC, we're just going to use it. The deployment is just going to use it. All of the connections between the database and the VMs. There is a lot of logic related to load balancer, related to security groups, related to, of course, the autoscaling group. This is the one. Related to autoscaling group, and then defining what the VMs should be in the autoscaling group. So the idea is this is probably something that people would be writing on their own manually every single time they want to run an application. And if you just want to package your Golang, Java, Ruby, whatever else application, if we know how to package it, we'll probably just ask you for the application. If we don't, we just ask you for a bunch of small scripts and the compiled version of the application. And then that's it. So this is the template. The other one is launching as we speak. It's going to take a while to get there. So what I can do in the meantime as well is show you some of the useful information that Stacksmith provides. So one of the things that we discussed was about knowing what's inside the image. Inside Bitnami, we do it slightly differently, but we thought right now we're tracking system packages. In the future, we also want to track other types of packages like NPM packages, Ruby gems, Java jars, and so on. We basically extract it from the image at the time the image building is finishing. And right now, because this is a relatively recent image, I just see the package versions. Not really interesting. But what's more interesting is if I take a semi-random application that was built longer time ago. Let's say this Ghost app. Hopefully it's going to have it. If I take a look at the system packages, no, because it was built quite recently. Okay, I need to take another random application. Okay, this one is older. So you could see that it was scanned for 4 days ago, and we can see that there are 74 updates available, which none of them are security issues. So I can see if I rebuild it today, what would be the changes. And this is mainly valuable for companies because they can manage their security, but this is obviously available even in the free plan. Like I said, the only difference is everyone can go in and see it. So we can see what would be the changes if I would click repackage. It would just be repackaged. One other thing worth mentioning is all of these operations are happening within your cloud account. So all of the files that get uploaded, we don't host them in Stacksmith. We just store the credentials that allow us to do the subset of operations in your cloud that you chose.
Question: if, for example, I would like to log some of the versions because I know that specific versions would break my functionality for whatever reason, can I do that?
You could do that in the build script. So, for example, we would be probably installing the latest version of Tomcat, but YAM allows you to install a specific version of Tomcat or a specific version of packages. There is also a thing called pre-hooks, which is slightly more difficult to set up because it requires you to create a custom stack template and inject a script there that's run before our build script happens. But you could also, at that place, you can say, okay, and freeze those specific packages. I'm more of a Debian Ubuntu guy, so I know how to do it in dpkg and apt. But I know for a fact that you can do it in RPM and YAM. I just can't tell you the exact command line from the top of my head, but you can definitely do it. It would show up that there is an update here. So right now we don't track the frozen packages. So, we would always see there is an update to Tomcat, but you should be aware that, okay, I explicitly froze this update, so it's fine. So this is the only thing that would change. By the way, all of this is also queryable from API, and we plan to have webhooks when updates are available. So you're able to write a periodic job in your CI that will just query Stacksmith if there are updates to the latest version of the image. If they are, you can choose to repackage it or not. So that's pretty much all in terms of this. We can go back to our previous image because I want to show the logs, and they are okay. We can see that Kubernetes build, obviously Docker images build faster than cloud images. What's interesting is we basically try to use open source projects and solutions. So in this case, or freely available ones or like popular ones. In this case, we're using code build for Docker, and we will actually see when I manage to scroll all the way up, we will actually see that we're talking to code build. We're sending some arbitrary files to a code build job that basically takes and builds it. So we're using AWS's native way of building, of performing jobs and building things. So we do that for the container, and we just have all of the logs. And this is basically using Dockerfile and Docker. So you will see that we have some arbitrary Docker file that we created that just uses the abstraction layer we have, and just copies all of the things and just runs installation scripts. In VM world, it's going to be more or less the same. It's still building, so I'm hoping I will actually see the logs, and I don't know what to blame. Like, is it the connectivity? Is it the cloud? Let's wait. Or not. Okay, so let's take a look at another application, at the previous application I built, because it's going to have the log. Okay. So here we're actually using Packer, which is an open source project, and there's nothing preventing anyone from going in and just, skipping Stacksmith, using Docker build, using Packer and doing it. We think what's interesting is we give a convenient layer. So we give you all of that for free, because if you would be using code build to do Docker build, you would be paying for AWS usage as well. If you would be using Packer to build the images, you would only be paying for the VMs that Packer spins up, because Packer itself is run in our setup. So Packer is not run within your cloud account, only the actual VM that Packer spins up. And for those who do not know, Packer is a open source project born from HashiCorp to just standardize building VM images. We just built tooling on top of it. So again, nothing preventing you from just taking it and building something on your own. We just hope that because we give it to you for free and it has added value, you can use it. So we just built the EMI and that's it. And it's probably going to be the same things that are happening in the container, just a different way of building it. Right, so it's built. We can now hopefully go back to our CloudFormation console and internet. CloudFormation command, okay. Yes, leave. So if there's nothing wrong happening, okay, creating progress. So it's still being launched. For those of you not aware about the details of CloudFormation, so it's basically, it took the template, it's just building all of the resources. So what's happening now is it created a database. Right now it's finishing creating the VMs themselves. So probably we need 2 or 3 more minutes, and I don't have anything launched.
So in this particular case, this CloudFormation template was sort of prepared for you because you picked already configuration. But if you would like to prepare something different, your custom configuration,
you can.
You need to, well, I mean, you need to have some kind of I don't know, Terraform script or something like that.
No, so we standardize on what we think. Like we have an opinionated choice of what we use for the deployments. We plan to support Terraform as well, but initially we decided that CloudFormation and ARM templates are the standard way of doing things.
But you also had Azure there.
For Azure, we use ARM templates.
So we prepared 2 different kinds of templates?
Yes, so yes, and we give you ones out of the box, but you can always define your custom one. So let's say, so you can say like I have the 2 of my ones and just like this one is obviously obsolete, but I defined a simplified one that basically just has the custom CloudFormation template and the customized Helm chart because we use Helm for Kubernetes deployments. And we have instructions how to do it and support page exactly. It's basically taking the template that you can download from any build and replacing a few placeholders like add image ID or something like this. We have some sample GitHub repository, and this is where you can plug in your pre-built scripts, right? So this is where you can, well, this is what you asked about. If you want to freeze something before any other thing happens, this is where you can plug it in. I think this is more advanced, so I wasn't planning on showing it. What I can show in the meantime before this thing launches and actually, oh, okay, it just matched.
I have a question.
Yes?
Can you talk a little bit more about well-architected? Because I think it's important to code.
Okay, so yes, so let me finish this and I will get back to this. So this basically run my application. This is my Java application. I think this is some example that I just took. And I can just say like, I don't know, Wojciech Kocjan, and it's just going to add it to the database. And this is basically my Java application talking to RDS. I didn't have to do anything in AWS. I didn't have to do anything anywhere. And if I just want to take it, but say like, okay, I don't really want the load balancer. I don't really want a lot of the features I want. I can just change my CloudFormation template. Now, the question Dano asked was interesting. Well architected. This is an initiative from Amazon. Amazon wants anything that you launch in Amazon to be as cloud native as possible, and they have a set of 5 pillars that are grouped as well architected. That consist of security, of optimizations. I don't really remember the pillars right now. For sure, there are things related to disaster recovery, backups. So basically, all of the things that you would be expected to plan in your production deployments. What we did was we worked with Amazon for a few months with the CloudFormation templates that we generate, with the way we build images, with what's included in the image and what services we use, to figure out all of the things that we can make possible. Like, for example, we don't do all the backups by default, but there was an option I had to disable about database backups because we believe that providing database backups by default is a convenient way. We provide load balancers. We define things like health checks for the VMs and so on, based on feedback from Amazon. There are some minor issues on the roadmap to even further improve it. There are some things also expected on the people making the deployments. For example, people are responsible for doing the disaster recovery, figuring out, testing how they would actually recover from backups if something goes wrong. This is not something we can tell people to. This is not something we can do for them, but we can tell them that people should actually be doing this, and it's somewhere in the StackSmith documentation as well. Now, what I want to show as well, and yes.
How do you manage to, for example, if I upload some application like Ruby application, which have dependencies on gems that are private, so that are stored inside, I don't know, my repository, that are depending on my GitHub account that is private with my company. How do you manage those?
That's a good question. So we have integrations, and I think those, I don't know if those are available in free plans, to be honest, because I don't want to promise things that may not be there for the free plan. But obviously this would be something more for a company profile. But we do have integrations with things like Artifactory, and then you can provide credentials. And then if you tell Bundler to actually fetch it from your repository, we can pass those credentials. So for example, we have the Git repositories, right? And then we have projects where people actually want those to be pulled from companies' own repository or private GitHub repositories or Bitbucket. We do have integrations for those. And the same applies for Artifactory. We have projects where people actually push their outputs into Artifactory. So by default, StackSmith, and this is kind of related because it all deals with credentials. By default, StackSmith pushes to, okay, maybe this one is loaded. Okay, by default, StackSmith pushes Kubernetes to, for example, it pushes to ECR, which is Amazon's container registry, and Helm charts are pushed to S3. But if you want to use Artifactory for Helm charts and if you want to use Artifactory for containers, this could be configured at the project level, and then everything would be pushed there. The same applies to inputs. If I would be using my own private GitHub or Bitbucket account, and if I give a private SSH key, then this would be, or actually I would get a public key for SSH. This is the other way around, that you get a public key that you need to associate, and you don't upload this private key. But I just need to set it up, and then it's going to be able to pull. Actually, what I want to show is I have a public, so there is no credential handling involved. I have a public project which is in my account. This is some CI example that is a clone of a generic example. Like, I'm not going to lie, I didn't write it end to end. So it has an application. It basically says hello world. So like hello Krakow. Just to do that. What I'm going to do is I'm just going to meet like hello. And that, and I'm just going to push it. Actually, I didn't have to even type that. So this is my repository. This is just basically pushing it to GitHub. Now, okay, it actually remembered it. It's connected to my Travis, which is just set up using the free plan as well, because I don't do that many builds, and it's completely fine. So it didn't pick it up yet. Okay. Okay, it picked it up right now. So this is actually just going to build my Go application, and it's going to take a while. So maybe I'll actually show the other things in the meantime, but it's basically, I'll just show the Travis file. Maybe this way. So basically, this just installs the StackSmith tool because I need it. Then this is just basically building my application. It's logging into StackSmith using the StackSmith CLI. So my Travis has this token set up there that is a way to log into StackSmith. And I just do StackSmith build, which is also a command. So this basically just takes the repository, figures out how to build things, and just reads this file and tells it what to launch. So I have those two scripts, and they're committed in the repository. So this script basically just takes my application file that's uploaded. That's the binary of the Go application, and it just copies it to opt up my application, and then the run script just runs this application. So as I mentioned, for applications that we don't know how to run, we're asking people, write a script that runs the application and does not exit until the application has stopped. So for example, for VM images, we integrate with systemd, so it's going to restart the application and I'll use all of the systemd's built-in functionality, and we expect your script not to finish. In Docker, we just run the script directly because it's just going to stop the container, and in the Kubernetes world, restart it when your script finishes. So this is another way of integrating with this, and this is just going to take, like, Travis is just going to build my application. It's going to have a lot of logs, and then it just basically runs stacksmith build, and stacksmith build kicked in here, and it says like this is where you can follow the build in the UI, but it's also pulling the logs in real time, and the logs are going to be there in Travis CI, so I can check my logs both from stacksmith and from Travis CI, and the CI integration is also available in the free plan, so you can. So for example, if you have an application and you just want to, provide an up-to-date version of the images, if you have the public plan, people cannot access your images because the images are private and in your cloud account, but they're going to be able to go to stacksmith and clone the same logic, or just fork your repository, change where the application definition is, and build it in their account. So that's what can be done. That's pretty useful if you actually have an open source project and want people to be able to use it. So you can see this just kicked off the build that I mentioned. This is the build that was kicked off by the CI. And if you have an integration with CI, you don't have to do anything in the stacksmith UI. It's just fully automated. So you commit the change in your application, and like 20 minutes later, I would be able to launch this application, and it will actually say, hello, Krakow. Obviously, I'm not going to wait 20 minutes unless we run into so many questions that I will be able to do it. But I think that's pretty much what I wanted to show, unless, okay, this build.
Show the scripts that you used for that Java application? Like
for the Java.
How do you integrate it?
Okay. Okay, so there's one really last thing that I want to show, which is more for companies, but obviously, come on, service catalog. Okay, I went to the wrong place. I hate the internet. I'll show the script, but I just want to mention one thing. Danu mentioned about service catalog, and he promised I will show you this. So, okay. So what I have is set up, and this is also not available in the free account, but you can basically write your own tool to have the integration. What I have is my builds. Some of my builds. Oh, come on, deprecated look. Some of my builds are basically being pushed to my account's service catalog. Service catalog is a kind of a private marketplace where your admins or your ops team in your organization can push images, and then you're only allowed to launch the images that were kind of certified by your ops team. So okay, so this is the application I built today that I tried to call, and the name was too long, Java app to show up in service catalog. So as soon as it's built, it's also being pushed to service catalog, and then it was pushed literally a few minutes ago. And then, if you have this integration set up, you can basically build applications in stacksmith, and as soon as they're built, people can actually go in and launch them, which is interesting if you provide a curated set of applications, because you can also have stacksmith rebuild them as soon as there are security issues, and it's going to get populated in your service catalog. So if you're a bigger IT company, you actually want to be able to do this. But this is just like, and if I launch it, I would go through the same experience as in CloudFormation. So I would need to I'll just quickly show it and then go back to the scripts. I'll basically have the same questions that I had before, just in a different UI. So I need to provide the same parameters to launch it, and then it would be launched via the service catalog. And this is an interesting feature that AWS is pushing strongly to larger organizations, because it helps manage the deployments in customers' environments. But about Danu's questions, so this is my GitHub project, well, not mine. This is Bitnami's GitHub project for this application. We actually do have instructions how to package it, but the scripts. So there are two scripts, or actually only one. So because we don't need to install any additional packages, there's nothing happening at build time. There are 3 scripts, and I'm just going to maybe show the scripts either from the Go application or from this Java application. There is the build script. Okay, there is the build script, which is run at build time, and you can install additional things or customize things. In this case, I just copy my application to the appropriate location. Then there is the boot script, which is run every time your VM or container is run. And the idea of the script is it is supposed to apply customization or configuration changes and exit. So in this case, this script is waiting for the database. The environment's database host, port, user, and password are set by all of the logic in Stacksmith. So this is another interesting idea. We expect that you're not really interested in how database connectivity details are passed to you. You're interested in being able to take them. So what we do is we wait for the database to be available, and those variables are set to the same parameters in all of the clouds. As soon as it's available, we use a flag file to just do it once, but we basically find the application, just in case someone uploads the WAR file with a different name we didn't hard code it. And we just write the Spring configuration, like this is how you connect to your database, and use SSL because the database may be using SSL for connectivity. These are the credentials, that's it. So this is your application specific logic. Like if your application, like this would be a Ruby application. If you would have full Ruby support, you would probably just generate database.yaml. If not, you would just write your configuration config/database YAML with the database configuration settings. And this is just expected to exit. So this is run before the run script. This is run before the run script. In the case of VMs, we do it using systemd. In the case of containers, we just run one after the other. Then the run script, as I mentioned before, obviously, the run script just runs your application, and it's expected not to exit. And you only need to provide the script if Stacksmith doesn't have the logic to run the application. So like, if this is a Java application, Stacksmith has the logic to run it. If this is a .NET Core application, which we know how to package as well, there are some standard ways to run .NET Core applications as well, so you don't need to provide it. But for our Go application, we just use a generic template which doesn't have a lot of logic inside, and we just had to tell it how to run it.
So preparing the images is one thing, but actually managing the change is the other. Do you have any ways to ease the pain of updating the infrastructure?
Yes, this is a good question. Yes, so we test all of the templates that we write. We test how to make them as easy as possible to update them. The mechanisms are going to be cloud specific just because there is no generic way. But for example, one of the reasons why we always use a load balancer and why we always use an auto-scaling group is the way CloudFormation is deployed, which I don't have a way to show right now that would be fast enough. CloudFormation has some optimizations for things like auto-scaling groups, is that it spins up a new auto-scaling group and uses the liveness checks to make sure that the auto-scaling group was set up properly. This is why we also configure the checks to be there. As soon as the checks prove that the auto-scaling group is working properly and the VMs are working properly, only then it connects the load balancer to the new auto-scaling group, and only then does it delete the old auto-scaling group. So for example, if your application supports, I don't know, database migrations and talking to the new and old schema, all of the things that would be expected, you're able to fully support migrations in all of the clouds with no downtime. You just have to do them differently for every single cloud. But I've been testing one open source chat application. I guess I can name it. I was actually trying to package Mattermost. And the issue with Mattermost was we had to use things like EFS for storing the files that you upload there, because that was a tricky thing, that the files disappeared because of the VM migrations. But if you would not be uploading files, Mattermost supported live migrations really well. The database migrations were done properly. The application would just be picking up the database and would just be handling it. The client was also designed properly because it detected the WebSocket disconnect that happened, and ELB supports WebSocket protocol well. So basically, at most, you had to just reload the client. If the client detected it properly, which was like, I don't know, like most of the cases it worked well. In some cases, I just had to kick it manually. But it was basically no downtime upgrade. And this is just because we decided we're going to add in the overhead of load balancer, we're going to add in the overhead of auto-scaling group. Because for example, we use an auto-scaling group But by default, this auto-scaling group, I hope I can click it, this auto-scaling group just spins up one VM. So you could say, like, okay, if you don't use auto-scaling group and spin up one VM, this is just going to be faster, which is true, but then you run into all of these issues with updates. So we did take it into account, and there's a lot of thought put into those CloudFormation templates, and you get all of that.
So if the things are going to fall apart at some point, am I able to roll back?
That's actually, so it varies on the cloud you use. Like, CloudFormation templates are really designed much better than Terraform and then ARM templates in terms of dealing with disaster, dealing with rolling back to previous version. If your application doesn't support that version A talks to the database schema of version B, this will not work. But if your application supports that you migrate the database and then roll back, it's going to work properly, because CloudFormation by design always allows you to roll back to a previous version, and it always does those incremental changes in such a way that it doesn't terminate previous resources until the new version of a resource is fully deployed. So I gave an example of auto-scaling group. We don't use that many other services, but for example, if you would be, well, RDS will not handle updates well, but if we would be using things like, let's say we use, what other services we are using. I can't think of a service that we would actually be using in Stacksmith that this would need to happen to, but let's say we use a service where in a new deployment we need to generate a new instance of that service. Let's say we use some caching mechanism in the middle, and our deployment changes some setting that requires it to be recreated. The old resource will still be there until the new one is recreated, and any resources that talk to it will be recreated as soon as this is deployed. So let's say you have a caching, and then the VM has to talk to the caching layer. CloudFormation will create a new instance of the caching. It will create a new auto-scaling group that talks to the new instance of the caching. Only then it will start deleting old resources. So if any of the creation fails, CloudFormation will just roll back all of the changes in it and just freeze up the previous version that was working. With ARM templates, that's not really the case, or at least I couldn't make it work, and the team couldn't make it work either to such a degree that it's not possible. But they do also have some really good use cases for incremental deployments, and we do support it to the extent where it's possible. It's just like it depends on who's doing what. This is, for example, one of the reasons why our opinionated choice on CloudFormation, not Terraform, because Terraform makes it much easier to end up in a broken or not fully recoverable state, and it's much more difficult to recover to an older version in those cases. So yeah, a lot of effort put into it. You can always shoot yourself in the foot if you want, but well, we can't prevent people from doing that. Okay. Any other questions or comments, thoughts? Anybody has a project that they want to use it in? That's not KubeVirt. Okay, awesome. Anyway, so if you have any questions, feel free to also contact us. Like I said, the public tier of Stacksmith is completely free to use. I guess aside from, let's say, enterprise or commercial grade quality features like integration with private repositories or private artifact repositories, everything else is free to use. There are no limits on the amount of builds that you could be making. In the end, the builds are made in your account, and everything happens in your account, so you get to pay for it. But all of the orchestration level that Stacksmith provides for managing this, all of the data that we store, this is for free. So all of the system package information, the analysis and the mapping of security issues to it is free. So I think that's all I had. Well, that's all we had. Thank you very much.
Thank you.